Hello there and welcome to Lower 6 Maths A-Level Practice Paper D. Here we're working on a differentiation question. Part A asks us to find dy by dx in terms of x. So differentiating this should be straightforward if you've had enough practice at differentiation. 3x squared minus 2x minus 1, and that's its differential. Finds the equation of the tangents to the curve at point P. So P is the coordinate 2, so we need to work out the y coordinate from here. So it's going to be 8 from 2 cubed, take away 4 from 2 squared, take away 2 from the 2, and add on 2, so our y coordinate is going to be 4. So we're working with the coordinate 2, 4 here. So we need to work out the differential when x equals 2, so the gradient, so I'm going to change my dy by dx to an m to stand that I'm working out the gradient here. So it's going to be 3 times 2 squared minus 2 times 2 and take away 1. So 2 squared is 4, times 3 is 12, take away 4 is 8, take away 1 is 7. You can just check this on your calculator, so if you go to the shift button and the integral symbol, it gives you a differential, type in your function, set x equal to the coordinate 2, and you should get your gradient of 7 there. Okay, so moving on, the equation to the tangent. So now we know that the m is 7, we set up a y equals mx plus c equation, and we plug in 7 as the gradient. What we can also do now is we can plug in the coordinate 2, 4. So 2 here is the x letter, 4 here is representing y, so it's 4 equals 2 times 7 plus the c. Take away the 14 onto the other side and you get c is minus 10. So the equation here is going to be y equals 7x minus 10. Okay, part C is the normal to C at P intersects the x-axis at A. Find the coordinates of A. So for the normal equation, m dash, this is going to be minus 1 over the gradient of the function here before, that was minus 1 over 7. So given that we're going to have y equals minus 1 over 7 x plus c, it's a different c now. So what we'll have had before is we'll have had a tangent, which will roughly do that sort of thing. We now have a normal, which will do that sort of thing. So the c's here, you can see, are obviously going to be different. The normal is at a right angle to it. So we can still plug in the coordinate 2, 4, which is going to get a different value for c. So 4 goes in the y position, minus 2 sevenths goes in the x position because it's 2 times minus the 7th, plus the c. So we get 4 plus 2 sevenths, so we'll call that 4 and 2 sevenths for now, equals c. So y equals minus a 7th x plus 4 and 2 sevenths. Okay, and we want to find when the x-axis intersection is. So we want, if it's a negative one, it's going to be roughly looking like that. So for the x-axis intersection point, the y coordinate here is going to be equal 0 because it's not going up or down by anything. So 0 equals minus a 7th x plus 4 lots of 2 over 7. I think what I'll do here is I'll times by 7 on both sides. So, and I'm going to add this bit over to the left hand side as well. So I'm going to get x equals, right, so 7 times 4 is 28. Add that on to 2 over 7 times 7, that's 2. So we're going to get x is 30 here. So the coordinate of A is going to be the coordinate 30, 0 here. 10 marks.